Hello everyone, welcome to the ITLS Academy. Today we are going to discuss the topic that is your non-ionic surfactants. Okay, so in the previous lecture we are discussed about the ionic surfactants, and along with it we are also discuss about the surfactants. Okay, so in today's lecture we are going to discuss about the non-ionic surfactant. So with all of these we are going to start the today's lecture. Non-ionic surfactants, the majority of non-ionic surfactants are condensation product of ethylene oxide with a hydrophobe. Okay, so basically, majority of the non-ionic surfactants are what? They are the condensation product. They are the condensation product and the condensation product of what? Just a minute. Condensation product. Okay, and condensation product of ethylene oxide. When the ethylene oxide are condensate, then we get a basically non-ionic surfactants, and they also have a hydrophobe. Hydrophobe. They also have a hydrophobe. This hydrophobe is invariably a high molecular weight material. They are what? They are a high molecular weight material, and they also have a active hydrogen atom. They are what? They are a high molecular weight material and also have a active hydrogen atom, and the non-ionic material can be one of the following reaction product. Okay, that we'll discuss in the next slide. Non-ionic material are what? They are basically a following reaction product. Either we get by a fatty alcohol and alkyl phenol condensate. What we get? We get non-ionic surfactants. So we get non-ionic surfactants either one of these reaction, that is your fatty alcohol alkyl phenol condensate, fatty acid condensate, condensate of ethylene oxide with an amine, and condensates of ethylene oxide with an amide, with amine or with amide. Okay, so the first that we are going to discuss is a fatty alcohol and alkyl phenol condensate. So basically the reaction is R have a single bond with O and single bond CH2 in a bracket OCH2 CH2 N minus 1 OCH2 CH2 OH, and A is what? A is your alkyl or phenyl group. Then the alcohol in ethoxylates and alkyl phenol ethoxylate are produced by the reaction of alcohol with an excess of ethylene oxide. Okay, so here a reaction are take place between the alcohol um, along with a excess of ethylene oxide. Then the two products are produced. One is your alcohol ethoxylate and another one is your alkyl phenol ethoxylate. And the reaction of one molecule of ethylene oxide is not sufficient to produce a water soluble detergent product. Okay, so one molecule of ethylene oxide is not sufficient so for the production of the water soluble detergent product, so we required a more than one molecule of this ethylene oxide. So here the reaction take place, that is your ROCH2 CH2OH plus N CH2 single bond CH2, it will attach to a O. It will convert it into a ROCH2 CH2 OCH2 CH2 in bracket 2n minus 1 OCH2 CH2 OH. Okay, where N is equal to 16 to 50 and R is equal to alkyl or phenyl. Okay, the ether linkage is a strong bond, therefore the material cannot be hydrolyzed. Okay, so ether linkage is what? Ether linkage is very strong bond. Ether linkage is very strong bond due to which the material cannot be hydrolyzed. Therefore, there is no possibility of ionization and subsequently it is not affected by a metal ion. So this reaction will not affected by the any metal ion due to the presence of the ether linkage, and this ether linkage have very strong bonding. That's why this material cannot be hydrolyzed and there is no possibility of the ionization. In practice, the optimum detergency is found in the range of 10 to 15 molecule of ethylene oxide per molecule of fatty alcohol, and the sources of the alcohol are varies greatly, but natural Ziegler and oxo alcohol of various molecular weights are used. And the another source of the alcohol is one used by a union carbide. Basically, 10 to 15 molecules of ethylene oxide are required for the production of the fatty alcohol, and the source of alcohols are vary greatly. Okay, but the natural source of this alcohol are Ziegler and oxo alcohol, and they are what? They are of various molecular weight are being used. Same type of, so another source of the alcohol are used by a union carbide. Now the next is your, these alcohols are obtained from a N-paraffin, which are oxide to a secondary alcohol. We get a alcohol from a N-paraffin which are oxidized to a secondary alcohol, and the ethoxylation of these alcohol is done into a two stages. The first product contain 1 mole of ethylene oxide, which is produced first with a help of the acid catalyst, and after this stage the catalyst and the unreacted alcohol are removed and ethoxylation take place as usual. When the reaction are completed, then some unreacted alcohol are left, and this unreacted alcohol along with the catalyst are removed and ethoxylation are take place as usual. Now the next is your, the alkyl phenol behave in a same manner as a fatty alcohol. The non nonyl or octyl phenol is widely used with 8 to 12 molecule of ethylene oxide. Nonyl phenol are completely soluble in water at a room temperature and exhibit a excellent detergency. Okay, we can use a nonyl phenol or octyl phenol with the molecular of 8 to 12 of ethylene oxide, but the nonyphenol is what? They are completely soluble in water and especially at a room temperature, and they also give a excellent detergency. Dodecyl ethoxylate is used in a certain agriculture emulsifier, and dinominyl phenol as low or non-foaming ingredients of the household washing machine powders. The alkyl phenol ethylene oxidate They are condensate and have been the most widely produced non-ionic detergent. Which one? Alkyl phenol ethylene oxide. Alkyl phenol ethylene oxide, they are condensate, and they also used as a like widely produced non-ionic detergent. These condensate are solubilized by the ethylene oxide unit and form a hydrate with the water. Then compare with all other type of the minerals, they are dissolved into a water, and the product which show an apparent anomaly, their solution are completely clear in a cold water, but when they are heated, then it will become a turbid. And when a temperature is raised sufficiently, there is a separation take place between two phases. One is your clear and one is your turbid. This explained by the fact that an elevation in the temperature, the hydrates are destroyed. Okay, it give a fact that when there is a elevation in a temperature take place, then automatically the hydrates are what they are destroyed. The next is your fatty acid condensate. They are another type of the non-ionic surfactants that are prepared by the reaction of fatty acid with the ethylene oxidate. This is your fatty acid and this is your ethylene oxide. Then we get what? R C double bond O O CH2 CH2 single bond O CH2 CH2 N minus 2 O CH2 CH2 OH. This is your fatty acid condensate. Okay, now the next is your these condensate can also be produced by the esterification of the fatty acid with a polyethylene glycol, that is your HOCH2 CH2 CH2 and CH2OH. Esters are the material that have some disadvantage as compared to the other non-ionic detergent. In general, non-ionic detergent are not affected by the metallic ion that we are already discussed in a previous slide, and they are also not affected by the acids of the alcohol, sorry, or the alkalis. However, the fatty acid condensate of this ethylene oxide, they are readily hydrolyzed by the acid or the alkaline solution to the corresponding fatty acid and polyethylene glycol. In a strong alkaline solution, these esters are no better than a soap of corresponding fatty acid. And in also a strong acid solution, they are much affected. However, they do a problem well as compared to a household detergent powders. Okay, now the next is your condensate of ethylene oxide with an amine. The condensation of alkyl amine with the ethylene oxide leads to a secondary or tertiary substitutes of the amine, and it totally depend upon the concentration of the ethylene oxide. So basically RNHCH2 CH2O CH2 CH2 N minus 1 single bond OCH2 single bond CH2OH R single bond N one side in one branch it is attached CH2 CH2O CH2 CH2N minus 2 single bond OCH2 CH2OH, or in the other branch CH2 CH2O CH2 CH2N minus 1 sorry N minus 2 single bond OCH2 CH2OH, where R is equal to C11 to C17. This is about the condensate of the ethylene oxide. This class of non-ionic surfactant has not been used largely in a cleaning detergent. However, it is noteworthy that these materials in acidic solution can also exhibit a cationic characteristic, whereas in neutral or alkaline solution, they show a non-ionic. Now the last one is your condensate of ethyl. Sorry, not a last. It is the, I guess it is the fifth one. Condensate of ethylene oxide with the amide. Fatty acid alkyl amide are amide of alkyl amines, and the fatty acid and the certain members of this class exhibit a detergency and other do not. It is not necessary that all the class will exhibit the detergency, but some do and some don't do. The non-detergent material are converted into a detergent by the method that is called a condensation with the ethylene oxide. Fatty acid alkylamide find only a little application in a laundry detergent. They are used as a foam coating, that is adding desired stability to the foam which is produced by a detergent. Small amount of these material as a conservants are capable of enhancing the soil, which is have a property of removal of the classical detergent as compared to a low washing temperature. Okay, so this is all about the non-ionic surfactants. I hope you will understand today's lecture. But if you have any query related to this topic, you can ask me in a comment box. Or for a further detail, you can follow the ITLS Academy on different platforms, that is Instagram, Facebook, Twitter, YouTube, WhatsApp, and LinkedIn. And subscribe our channel ITLS Academy on YouTube and get our app from a Google Play. Or you can also ask your query to the helpline number that are already mentioned in your slide, that is 7080833450. Visit our website www.itlsacademy.com. Thank you for watching. Please like, share, and subscribe our channel.